We'll take another look here at the reciprocal function and the reciprocal of the square function, which we discussed already in lesson 2. However, now we'll look at them as rational functions. Both are quotients of two polynomials. Polynomial in the numerator of both of them is 1. Polynomial in the denominator for reciprocal function is x. For the reciprocal of the square function is x squared. Both functions have restricted domain. We do not allow 0 in the domain for both of them. And this translates to the specific property of the graph. There is no point on the graph that has x coordinate 0, and therefore the graphs of those two functions consist of two pieces, one for x is less than 0, one for x is greater than 0. The reciprocal function has this property that if x is the small value, then its reciprocal is large, and vice versa. If x is large, then its reciprocal is small. So if I choose my value x over here, for example, close to 0, the corresponding point on the graph is right here, and this is point x and 1 over x. If I take the point closer to 0, then the value of y is going to be larger and the point on the graph is going to be higher. So what this tells us that if the values of x will come closer to 0, the point on the graph is going to be higher and higher. However, the point will be always to the right of the y-axis, and the closer I will be here to the 0, the higher on the graph I'm going to be. So the graph, we can say, when x approaches 0, the points on the graph will increase, it will go up, the values of y will increase without bound, but that point will be always to the right of y-axis. The graph will approach y-axis but will never reach it. Such line is called an asymptote, and because it's a vertical line, we call it vertical asymptote. The same behavior is shown for the reciprocal of the square function. The y-axis, or the line x equals 0, is also a vertical asymptote. Now, if you look at the behavior of the function when x increases without bound. So now if my x is increased, then the values of y will decrease. So the further I am on this number line, so the larger my value of x, the value of y is going to be smaller and smaller. And therefore point on the graph of that function when x increases without bound will be approaching the x-axis. It will never reach x-axis because if x is a number, then its reciprocal is going to be non-zero. So the graph approaches x-axis, and we call the x-axis asymptote, but this is a horizontal line, so we have a horizontal asymptote. So this rational function has two asymptotes. It has the vertical asymptote and the horizontal asymptote, and the same behavior is shown for the reciprocal of the square function. We also have here horizontal asymptote. The behavior of the graph of those two functions is different in the sense that the reciprocal function has the graph symmetric with respect to origin. It is an odd function, and the graph of 1 over x squared is an even function, so it's symmetric with respect to y-axis.